everyone, this is Dr. Sandeep, working as Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about the composite materials and its applications. So generally, what is a composite? So composite is nothing but it's a combination of different materials. So different materials are layered by each other, and if it is impacted to a certain load and if we make it as a single material, then that type of material is called a composite material. So composite material is defined as the materials formed by the combination of two or more. So it should be more than two materials. Then that type of material is called as a composite. So single materials are different with the composite materials. So what are the materials which is having only single metal or single atoms are called as a normal materials. But a composite material is a combination of two or more. It should be a two or more material, then the combination refers to the composite materials. And the properties also varies. So that means if it is having two different types of materials, what is happening? Each material will have its own properties. Now if you combine these two materials into a single material, so the properties can be enhanced with the help of these composite materials. And what is happening? These two materials, they does not dissolve into each other. So what are the materials we are having in the composite materials? So these two materials, what are the two materials or three materials, what are the materials we are adding in the composite materials? They does not dissolve into each other, but they will look like a single material. So when you compare the polymers, what we have discussed in the previous session, in those polymers, what is happening? The polymers are having many number of materials or many number of parts. So they can be dissolved into each other. But in coming to the ceramics, what are the materials we are having that does not dissolve into each other? So that is the difference you have to make between the polymers and ceramics. So the polymers, what are the polymers we have discussed? So these polymers are also having many parts inside the body, but they dissolve into each other and look like a single material. But coming to the ceramic composite materials, the composite materials are also having more than two materials, but they does not dissolve into each other. So that is the difference you have to differentiate between the polymers as well as the composite materials. Now, the combination of different constituents in the composite provides the composite materials with unique properties. Why you are having unique properties means, so if you have A as a one material, B as another material, C as another material. So what is happening here? A is having some property, B is having another property. Similarly, C is also having another property. Now what is happening here? A, B, C are having individual physical as well as chemical properties. Now what I do, I'll combine all these three, A plus B plus C. If I combine all the three materials, what is happening? What are the material properties we have in each individual properties? So what is happening when you combine these three materials? So these three materials will have some unique properties. Why? Because all the properties of each individual A, B, C are being combined with each other, so that you can enhance the properties of these composite materials. That's why it is having a unique properties which is different from the individual constituents. That means A plus B plus C is having more property compared to physical as well as the mechanical properties when you compare with the individual. So A will have less than A plus B plus C. That means A plus B plus C is having some unique properties when you compare with the A material. So that is what the difference you have to identify between the single or individual constant material with the combined material. Like this, a composite material is being defined. So these combinations of all the materials will have some enhancement in the properties, that is called the uniqueness in the material properties when we compare with any type of material with the composite materials. Now in general, the materials comprises the main components. So what are the main components involved in the composite materials? So we have some three different components. So first one is the matrix constant continuous phase. So what type of matrix inside? That means how the materials are being aligned with each other. So that is the matrix formation inside the body. So that is the first component. what you have in the composite materials. So second one is reinforcement or the continuous or discontinuous phase used to strengthen the composites. So how we are combining the material. So that is called the reinforcement. How we are combining the material either by adhesives or by the impact of the forces. You are combining the two different materials. So it is not that much easy to combine two different materials which is having two different properties. So you have to use some different techniques. That is called the reinforcement. That means you're trying to combine two different materials to a single material. So for these techniques, you have different hot processing or cold working process or the reinforcement. So what type of reinforcement you are giving? So that is also one of the important component in the composite material. So that is the second one. And the third one is interface region. How the interface is being incorporated between the materials. That is the another component, which is the three main components involved in the composite materials. So the first one is the matrix or the continuous phase. Second one is the how the materials are being reinforced with each other, and the third one is the interface region between the materials. So these three are the main components involved in the composite materials. Now the composite material can be indeed found in the majority of the common products, including building and engineering, medical applications, energy transportations, aircraft, automotive, and other fields. So most of the technology what we are using nowadays is being a composite material. So if you take an example of any engineering project, so this engineering project, it is not a single material. It does not consist of a single material. So what are the construction building we have? So in that what we have steel, concrete, sand, cement. So all these are, we are trying to mix all these materials and trying to make as a single column. Okay, so this single column consisting of different materials. So it is a composite material. So it is having steel, concrete, cement, and sand. So you are mixing different materials to look like a single material. So that is one of the examples based upon the constructions. Now coming to the medical applications, even in the medical applications, what are the medicines we are using? It is not a single composition. You have different compositions of different medicines to cure whatever the disease we have inside our body. Okay, it does not take any single medicine. It is a combination of different things. Okay, so that is one of the examples of a composite related to the medical applications also. And coming to energy and transportation. So energy, what are the energy we are generating? Okay, that is again, does not a single thing. So again, it is a different combinations, how we are converting the solar energy to the working energy. So it is again a combination of different formations, transportations, even the roads what we are laying. So that is also different combinations we are mixing and we are trying to lay down the roads. And aircraft, automotives. So automotives, if you manufacture the automotive body with a single material, it does not resist different applications of forces. So it should be a reinforcement. The reinforcement means the combination of the materials should be very strong with high applications of the forces we have to do. So that's what you have n number of applications using these composite materials in any type of sector what you're considering, whether it is a civil, mechanical, or any energy or electrical, anything. So it is a uses of these composite materials is very vast and you have very wide applications in order to increase the lifetime of the material as well as the enhancement in the mechanical as well as the physical properties. Now, if you see the different types of composite materials, how these composite materials are being available. So first one is the composite material. So that is divided into two. First one is the type of matrix and reinforcement. So first, the composite material is being classified based upon the matrix, how the matrix is being classified in different forms. And another one is the reinforcement, how these two materials are being reinforced together. So that is about the basic classifications of the composite material. Now again, the matrix type is divided into ceramic matrix, or under ceramic matrix you have glass, aluminum, silicon, and etc. Now, the main characteristics, the matrix type, again it is subclassified into polymeric and metallic matrix. And again, these polymeric matrix is being classified thermoplastic and thermostatic. So all these are nothing but how the material is being matrix inside the material, how these are being combined with each other. So that has been classified into different forms. And again, coming to the other side of the reinforcement between the two materials or three materials, whatever how many materials you are using, n number of materials, how the reinforcement between these two materials, again, it is being classified into fiber reinforcement and structural reinforcement. So what are the wings for the wind turbine blades or the wings for the aeroplane or aircraft? All these are being reinforced, plastic reinforcement, okay, glass reinforced components. That means you're trying to reinforce different types of materials to look like a single material. In this case, what is happening? We are trying to increase the properties, and also because we are using the glass reinforced material, what is happening? The weight is also getting reduced. So that's why these composite materials are very useful in any type of applications. Okay, based upon if you want to reduce the weight, or if you want to increase the efficiency, or if you want to increase the properties, all these things can be achieved with the help of these composite materials, because it is having different types of materials combined into a single material to get the unique properties in these types of composite materials. Now, what is these matrix? We have seen matrix material. The primary function of this matrix material is the polymer composites. So to act as a binder and transfer the load between the constituents of the material. So binding is nothing but, if you want to bind some different types of materials, what you have to do? You are combining these different layers. So I have different types of materials like this. What I have to do? If I want to make these four materials to form into a single, what I have to do? I have to bind these four materials. Binding means coming to close to each other. All these materials, there should be no gap. There should be no air gap between these. I'm trying to bind these four different materials to look like a single material. So that is the importance of the binding. So that's what the matrix. The primary function of these matrix is to bind the composite different materials by using some load between these. So if you apply some load on this, then only you can bind these materials and look like a single materials. And polymer composites use generally two types of matrix. So what are the different types of matrix we have seen? There is the thermoplastic and thermosettings. So what are the matrix we have? So this matrix is helpful for us to bind these materials. And generally the polymer composites are having two main matrix types. So what is that? First one is the thermoplastic and another is thermosetting. So we'll see what is the thermoplastic and thermosettings in the coming slides. Now, since the composite era, both materials have been used for development of the composite. So what are the composite materials we are using? So these composite materials can be very useful in different applications, like as we have discussed, like the constructions, engineering applications, civil applications, electrical, even the computer applications also. It doesn't have only single material manufacturing materials. We have different types of materials in order to resist some heat. So energy generation, during the energy generation, what is happening? Huge heat is being generated. So what are the material we have? This material has to withstand that high amount of heat. So in order to withstand the high amount of heat, the plastic insulation what we are using, it does not resist. So what we are trying to do, we are adding some other material to the plastics so that it can resist to, though it is providing a high amount of heat. Like that, you have to use these composite materials to the applications. Now, what is the difference between those matrices we are using, whether it is the thermosetting or thermoplastic? So thermoplastic can be heated and softened and then molded or shaped upon the cooling to hold the desired shape. So if you want to get any type of material into the desired shape, the composite materials, what we have to do? First we have to heat the material, and what we have to do, and then soften into the mold. So whatever the shape you want to prepare, in that mold you have to insert these heated material. Then upon cooling, you can get the required shape. So that is about the thermoplastics. So thermoplastic has the property, when you heat the material, it can mold into any type of shape which you want to prepare. So how can you get that? After heating, then pour that molten metal into that mold, and after the cooling, then you will get the required shape. So that is about the thermoplastic. And what is the another point you have in the thermoplastic here? It has one or two structures, dimensional molecular structures, and they tend to show an exaggerated melting point at an elevated temperature. Since it is having the melting temperature, if you want to get the required shape using these thermoplastic settings, so what is happening? Since you are preparing the material to the elevated temperature, then it is converting into the molten metal state. So after getting to a molten metal state, you're trying to pour that liquid into the mold to get the required shape. So that is about the thermoplastic. And coming to the thermosetting, so what is the difference between these two means? Thermosetting materials endure an irreversible chemical bond reaction, that is the cross-linking or curing during the process to change the phase from liquid to solid state. So completely different, the thermoplastic and thermosetting. Here in the thermosetting, we are trying to do the chemical bonding between the materials to get into the required shape. Here in thermoplastics, we are trying to heat the material to get to the required shape. But coming to the thermosetting, we are trying to do the chemical bonding between the atoms inside the material and trying to get the required shape. So that is between that is the basic difference between the thermoplastic and the thermosettings. And coming to other difference, these thermoplastics can be recycled, remold, and reshape capability with the application of heat, ease of manufacturing. So since what are the materials we have in the thermoplastics, these are tend to the elevated temperatures. So that's why what are the waste material we are having? This waste material again can be recycled. This can be reused, and again you can prepare the required shape. So that is the main thing you have in the thermoplastics. So that's why it is having a recycle, remold, or reshape. So whatever the shape you got, if you have any differences in the shape, again it can be remold or reshaped. How means by the application of heat, we are trying to do all these things. So that is the main point you have to remember in the thermoplastic. But coming to the thermosetting, since we are doing only the chemical bonding, so we cannot again do the recycling or reshaping of the object what we have done. So in the thermoplastic, that is the main advantages of remolding or reshaping capability which we have with the application of heat. And chemically retardant and impact resistance, and it is closer to the environmental friendly to get the processing by adhesive to the metal. So it is also very free for the environment. That is about the thermoplastic. And coming to the thermosetting, we cannot do the recycling process here. Once it is done in a single one shape, it cannot be reshaped or recycled. So that is the drawback when you compare the thermosetting with the thermoplastic. So main thing is what? With the application of heat, we are trying to melt the material to the recrystallization temperature. So what is the molten metal we are getting? We can pour into the mold and get to the required shape. And if that shape is has to be changed into any other shape, we can do the reshaping or remolding with the application of heat when you compare with the thermoplastic. But when you come into the thermosetting, we cannot do any type of reshape or remolds. Okay, only the chemical bonding has to be done between these. So that is one of the drawback of the thermosettings. Now, if you see the structure of the thermoplastic as well as the thermosetting, so this is about the thermoplastic structure you can find, and thermosetting. So here we can see the bonding, chemical bonding between the atoms inside. That's why it can, once it is bond, it is bond. You cannot do the reshaping. But here, thermoplastics, because of the high amount of heat you are giving, it can melt into a different shapes. So that's why it is a recyclable thing you are having. But in this case, since all the atoms are being bonded with each other, we cannot do the recycling process. So that is what the difference, the main difference, depending upon the type of matrix we are incorporating in the composite materials, whether it is a thermoplastic or thermosetting. So based upon the thermoplastic, if any composite material is being prepared with the help of thermoplastics, okay, these types of composite materials can be reshaped or recycled. But any composite material which is manufactured or prepared by the thermosetting process, then those types of composite materials cannot be recycled. You cannot change, we cannot alter to any shape. Once one shape is fixed, it is fixed. And this only one application it is. But coming to the thermoplastic composite materials, though you're doing some manufacturing and you're doing some application, and again the material, whatever the applied material is there, this material can be again reused, okay, by the application of some heat process, and you can apply it to any other applications. So that is the main difference between these thermoplastic and thermo settings. And coming to the other thing, some types of material, what are the examples of these thermoplastic as well as thermo settings? You see the thermoplastics examples. You have the materials used in polymer composites like butadiene, sterline, polybendamizole, polyethylene. So these are some of the examples of the thermoplastics. When you compare with the thermo settings, you have very limited things. Why? Because it cannot be reused. That's why you have very limited type of composite materials when you compare with the thermo settings. So polyviscaline, so phenol silicon, okay. So the urea formal, dehydrated formal polymers, all these some of the examples of the thermo settings. So main thing is what? The composite materials which are being prepared with the thermoplastics are having huge applications when you compare with the composite materials which are being prepared with the thermo settings. So that is the main difference between these two. Next, that is about the matrix type of manufacturing process when you compare with the composite materials. Now another type of category is what? Fiber reinforcement. So how we are trying to reinforce these composite materials, how we are trying to combine these two different materials into a single materials, that is the other category which comes under the reinforcement between these two materials. So first one we have seen about the matrix, how the matrix is there between these two materials, whether it is a thermo setting or thermoplastic. Now another category is about the reinforcement of these composite materials. So in fiber reinforcement polymer composites, so what we have here, we have different types of fibers that can be reinforced material. So we are trying to, if you take these two materials, okay, so we are trying to bind these two materials into a single form. So what we are trying to do, we are trying to reinforce very closely with each other, closely packed. So it is a combination of A plus B plus C, A plus B, and again if you consider this C. So you have all, any point, if you see at any point, you have all these things, A plus B plus C, around any type of zone. That means you're trying to reinforce all these materials into a single material to enhance the mechanical properties. So that is the beauty of these reinforcement of these materials. Now the selection of reinforced materials is depending upon the end application. So what are the material we are selecting? This material has to be applied. So depending upon the type of applications, you have to select what type of material is useful. So how can you select these materials? You have to find out each property. If you know the property of each individual material, then what you can achieve? So by adding all these, you can get some uniqueness in these materials. So since if you compare this material with the A plus B plus C is having some uniqueness. So this uniqueness is having different properties when you compare with individual material. When you compare with the individual material, so A plus B plus C is having very uniqueness. So this unique property can be applied in any aerospace engineering or any type of energy sector. So like that. But this single A cannot be applied in aerospace applications or energy sector. Why? Because it is having very less property. But if you add some another material into this A, what is happening? There is some increase or enhancement in the properties. So that's why the end application is very important. If you know the application, then you can easily select what type of material is useful to that applications. So before selecting the material, you have to know the properties. What are the physical properties? What are the mechanical properties? Then only you can decide, yes, this material is suitable for that application. So like that, you have to select the material. So what type of fiber reinforcements are there? We'll see one by one. So first one is the glass fiber reinforcement. So in the name implies you have the glass. So these glass fibers are being reinforced. So generally we have the fiber generated from the silica based or other formulations of the glass by heating at 1675 degrees centigrade. So at this temperature, what are the silica based material we have? These has to be heated, then we can get these type of glass fibers. And if different types of glass fibers again we have. So what are those? First one is A glass. So all these things we are classifying based upon the properties. So at what temperature you are heating that fiber material, and depending upon the temperature, again these properties are being varying. So depending upon these properties, again these fiber classifications have been classified. So first one is the A glass. So A glass is nothing but the alkali glass. So here you have good chemical resistance but low electrical properties. Though it is having a good chemical resistance, so if this A type of glass is exposed to any type of chemical reactions, it can resist the material. But when you compare with the electrical properties, it is having very less thermal resistance value. So that is one of the drawback when you compare, when you see the A type of glass fiber reinforced material. So C type of glass materials are called chemical glass. So it is highly chemical resistance material. So again, this type of C material is also can resist to any type of chemical reactions during the working process. Now the other thing is E glass. So electrical glass. So that means it is an excellent insulator and water resistance. So depending upon the type of applications, we are trying to segregate all these things. A glass, C glass or E glass, S glass. So how we are differentiating means based upon the applications, based upon the properties. So if you know the properties, then if any material which is exposed to some chemical reactions, then what type of material we have to do? We have to select whether it can be A or C. Why means it is very resistant to chemical resistant to chemical reaction. So that's why we can select either A or C. But if you want to get any metal which is exposed to electrical thing, then E type of glass you have to select. So that's why once if you want to select any material, before selection of material, we have to know the properties of each individual material. Then other type of glass reinforcements, S glass. So this is a structural glass. It is a good mechanical property. So any metal which is exposing to different types of loads, whether it is a tensile load or a compressive load, so this has to resist. So then what type of metal you have to select? We have to select S type of metal because it is having very good mechanical properties. So like that, all these different types of glass fiber reinforced materials have been classified based upon its applications, like A glass, C glass, E glass and S glass. And another type of glass is D type of glass. So this is a dielectric glass. So it is having some properties of good electrical properties but poor mechanical properties when you compare with the E and S. So though it is having a good electrical properties but very less in mechanical properties. So that's why you have to select the material which is having a good property depending upon your end application. So once if you know your application, so based upon the application, so there's just a reverse engineering from the application, your selection of material has to be done based upon the properties. So ECR glass fiber, again it is called as the electronic glass fiber. So this is electrical resistance, chemical resistance, good mechanical properties and also waterproof compared to E glass. So like that, there is an improvement in the composite material. So how we are trying to generate or how we are trying to manufacture all these things means once if you do some experiment, then only you can identify what are the drawbacks. So in order to overcome those drawbacks, we are trying to bring out some different materials depending upon our application. So in this case, you have these types of properties. The ECR glass fiber, that is called electronic glass fiber, is very electrical resistance good material, and chemically also it is very resistance. Even the mechanical properties are also good, and it is a waterproof when you compare with the E glass type. So this is the some type of glass fiber material. So you have different structures here, different types of metals have been reinforced, okay, and it is looking like a single, but it is having different compositions inside the material. So this is one of the examples of a glass reinforced material. And another type of glass reinforced, you have alkali resistance. So specifically it is used in concrete. So it provides strength and flexibility to the concrete in order to prevent the cracks. So that's what, if you know the end application. So if you want to avoid or prevent cracks from the structural thing, so you can use these types of alkali resistance glass. Next one is M glass fiber. So it is consisting of beryllium in its composition, and also it provides better elastic compared to E glass. So if you want to have a good elastic properties, then you have to go with this type of M glass. So another thing, Z glass fiber. So it is produced for transparent component, high mechanical, UV, acid alkali, salt, starch, wear temperature resistance, and also it is used in the 3D printer filament. So these are some of the different types of fiber glasses. You have different classifications. So these classifications have been done based upon the applications. And another type, you have carbon fibers. So carbon fiber is composed of carbon atoms bonded together to form a long chain, and these carbon fibers are extremely stiff, strong, and light compared to a glass fiber. So if you want to have any very lightweight material, so then that we have to select the carbon type of fibers, and also it is having very stiff and strong. So that is what important. So a very extremely stiff and strong type of things, and also the lightweight. So if it is a lightweight, then the efficiency will be very, very high. So in that case, you have to select these types of carbon fibers when you compare with these when you have to compare with the E-glass fibers. And the fibers are extremely stiff, strong, of course, and low weight to strength ratio, low efficient of thermal expansion. Though you are giving high amount of heat, it is having very, very less expansion. So if any metal is expanding continuously, what is happening? At some point it breaks. So but these type of carbon reinforced materials are very, very low in thermal expansion. So if you have very low thermal expansion, it is very, very useful, and it is having good resistance to chemical as well as high temperatures. So since it is resistance to high temperatures, that's why it is having very low thermal expansion, and also it is resistant to chemical reactions. So that's what these are the see, like that you are trying to improve different types of fibers, whether it is a glass fiber or carbon fiber, based upon the applications. So based upon the applications, you're trying to invent different new materials, and because of these things, there is some improvement in the properties, whether it is a chemical or mechanical properties. So in this case, these are having very less thermal expansion, and it is very good resistance to chemicals as well as the high temperature conditions. And based upon the modulus of elasticity, strength, and the treatment for heat treatment process, these fibers can be classified into different categories. Again, so what are the classifications we have? Based upon the mechanical properties only, or whether it is a chemical properties only. So like that, in the same way, as we have seen the glass fibers, how they are classified, in the same way, the carbons are also being classified based upon these properties. So ultra high modulus UHM. So this is having 450 gigapascals of modulus of elasticity. And another thing you have, these comes under type 1 heat treatment of carbon fibers. So depending upon your type of property, these carbon fibers have been classified like UHM, HM, that is high modulus, and intermediate modulus, and high tensile. So all these are different types of classifications you are trying to do based upon the properties. So this is one of the another type of carbon fibers in which the composites you're having. So Aramid type of another type of fibers you have. So these Aramid fibers have been invented by Kevlar. So that's why it is called Kevlar fibers. So this he has been processed. Why? Because you want to have some good strength and good resistance to abrasion, chemical reactions, and non-conductive, low flammability. So that's what. Once if you know the application, to what application you want to have, okay, the end application, if you know clearly, for that end application, what type of material you have to select. So if you select this material, so what are the applications you have to know. So once if you know the application, then depending upon your applications, you can try to bring out some new material with these types of properties. So this is one of the type of composite fiber which is having good impact resistance, and it is also used for the ballistic application. So where huge impact loads are being applied, Okay, so armor also the military people what we are wearing the armors. So these armors can be used with these type of Aramid fibers. So that's why it is used in the ballistic application. So because it is resistance to very high impacts on the body. Okay, so that's why these type of ballistic applications can be used with these armor fibers. So based upon the location of the chemical bonding of the structure, these Aramid fibers have been classified into two types. First one is the meta Aramid. So again, how we are classifying the glass or the other type of carbon fiber based upon the application. Similarly, these Aramid fibers are also have been classified based upon the applications or based upon the properties what we have. So in this case, you have a strength of meta Aramid fiber is very low than the para Aramid, and these fibers have very good thermal, chemical, and radiation resistance. So that's why depending upon your applications, depending upon the properties, you are trying to classify these types of fiber conditions. And this is the pyramid type of material what you can see. So it is look like some yellow type of things. So mainly these types of fibers are widely used in civil engineering structural applications. So in order to prevent the crack formation, so mostly the civil engineering structural application, these types of fibers are being used. And another type of classifications of the composite material is natural fibers. So natural fiber reinforcement components have been become very popular for many years due to their good characteristics. So all these are being classified or differentiated based upon your applications. So due to government policy and environmental conditions, these natural composites are being increased. Why? Because you have n number of applications based upon the natural fibers when you compare with any type of other fiber materials. So natural fibers have low dense means very lightweight and specific strength and provide good thermal and acoustic insulation. So these natural fibers can be it is having very less density, and also thermal expansion is very less, and it is a good thermal resistance material. So these are all some of the good properties what you have in the natural fibers. These are being derived from the plants and the animals. Okay, so these are fibers are very useful, and these are being available naturally from the plants as well as the animals. So these fibers have an edge over synthetic fibers in various sectors such as automobiles. We can use these fibers, construction, support industries with glass fiber reinforcement. So like this, you have different applications of these natural fibers which are being available naturally. We are not generating them. These are all the fibers which are being available, synthetic fibers these are called, which are coming from the plants as well as the animals. And how we are trying to classify these natural fibers. So first one is the plant, we are getting from the plants, animals, and mineral fibers. So from the plants, we have wheat, straw, rice stalk, barley, bamboo, soya stalk. All these are we are getting from the stalk. And if you see the leaf type of things, sislal, banana, so palm, like that, you have different types of fibers which are being available naturally. From these naturally available polymers, we are trying to generate some new composite materials to the application. So similarly, from the animal sector also we can get these type of different types of fibers which are being available naturally, and these are some of the mineral fibers what we have. So like that, all these have been classified based upon the applications and based upon your end applications. So how we are trying to reinforce these different types of materials. So as we discussed, different materials have been reinforced to look like a single material, either by using some binding between these two materials. How we are trying to do. So this is a particle reinforcement. So different particles are being incorporated inside. These different particles have been binded with each other to look like a single. So this is one of the particle reinforcement, and short fiber reinforced. So when you compare with the particle and short, you can see the difference between these two. So particles, you can see small particles have been binded with each other to look like a single. And these are the short type of reinforcements. So when you compare again the properties between these two, they'll have some difference in the properties. Again, if you see the differences in the properties, the applications will vary. And this is one of the laminates. So laminates means layer by layer. So as we discussed, different layers A, B, C, like that. So each we are laying one over the other, and after placing these layers, we are binding them together to look like a single. So these are called the laminated sheets. So whatever the laminated sheets we are using in the woodwork, so you have different materials. So why we are trying to laminate these materials means to improve the properties. We are trying to use these things. So like that, you have unidirectional fiber reinforcement bilateral. So see, if you see the structure, you can easily identify what type of reinforcement we are doing inside the material. So these are the classifications based upon the reinforcement of the structure. So in this session, we have discussed about what are the composite materials, how the composite materials have been classified, and based upon the type of matrix, based upon the reinforcement. So again, based upon the classifications, we have two different things, matrix things, that is thermosettings and thermoplastics. These are the two main things we have to identify in selection of any type of composite material. The other category is about the reinforcement, whether it is a glass reinforcement, fiber reinforcement, or naturally fiber which is being available from the plants and animals. Okay, based upon different types of end applications. Okay, we are trying to select whether it is a carbon glass reinforced or E type of glass reinforced material. So each application is very useful depending upon your properties, whether which property is useful to that application we have to select. Okay, so now if you see different applications in this, you have a lot of applications using the composite material. So any sector you can see, you have n number of materials which are being composite. It is not a single material. So space applications, you have antenna, what are the radar we are using, the satellite structures, okay, solar reflectors. Also, these are all made up of different types of material. It is not a single material. Even in the aircraft, what are the aerofoil surfaces we have, the compressor blades, engine body, fan blades, all these are made up of composite materials only. Coming to the automobiles, we have the automobile body. The body, when you are traveling, you can resist with some different forces which are acting on the body. So all these forces has to resist. So a single material cannot do all these things. That's why we are trying to prepare different using different composite materials. So bumper, mudguard, door panels, dashboard, okay, fuel tanks, CNG cylinders. All these are some of the main examples in which the composite materials are playing a key role. And wind turbine blades, what are the rotor blades we have? So all these rotor blades are being manufactured with the help of these composite glass reinforced fiber or fiber reinforced materials. And sports, surfboards, windsurfs, table tennis, all these are the examples of the composite materials. Okay, so this is about the composite materials, applications, uses, and classifications. So if you want to refer the topics about the composite materials, you can go with this introduction to physical metallurgy. And the second one is essential of material science and engineering. The third one is material science and metallurgy. And the last one is material science and engineering. So these are some of the references where you can get about the information about the composite materials and its classifications, and its how the microstructure of these composite materials, and where you can apply the composite materials, and what are the variations in the chemical properties, and depending upon the chemical properties or the physical properties, how we are classifying different types of, whether it is the E-glass type of things or S-glass type of things, or carbon reinforced materials, or whether it is a natural type of fibers which are being available for these composite materials. Okay, thank you for the session.
Like, share and subscribe. Hit the bell icon for more updates.